Alright, so let's look at this collision problem. We have two boats. The first one over here in the red has a mass of 0.132 kilograms. We have a blue boat headed toward it at 0.2867 kilograms. We know that they both go 2 meters in. The red boat takes 6.61 seconds. The blue boat took 9.97 seconds. We want to figure out after the collision, they crash. So after that, how fast are they going? So we want that final velocity. We're not quite sure which direction that is, so I'm going to call to the right positive, that would be V1, and I'm going to call to the left negative, that would be V2. Alright, so let's move these guys. We'll move this as well, shrink this down, and take a look at before and after the collision. So we know that regardless, the momentum we have before the collision is going to be equal to the momentum you have after the collision. That's the conservation of momentum. So I know that to be true, and that's where I start on any and all of these problems. So I have M1 V1 for the first boat plus M2 V2 for the second boat. All that's got to be equal to the total mass. There we go, total mass times that final velocity. Alright, so if I know that, I can start plugging stuff in. So for the first boat, I have a mass of 0.132 kilograms. The velocity I don't have directly, but I know the distance in time. So velocity is distance divided by time, at least for an average velocity. So that would be 2 over 6.61. And then for the blue boat, I have 0.287 kilograms in 2 meters in 9.97, so a little more massive, but not quite as fast. And I have a total mass of, well, both of them put together. And let me go back to my purple, because I like to be color coordinated. It's 0.419 kilograms at some velocity that I don't know. Alright, so now I just got to solve for velocity and do a little bit of math here. So I go back over here, I have 0.132 times the velocity of the red boat, which would be 0.3026. It'll be a little bit longer than that, but I'm going to keep that in my calculator. And then I have the blue boat, which is going, or has a mass of 2.287. And now this blue boat's going to the left, so this is going to need to be a negative 0.2006 meters per second, approximately. It's going to the left, and I got to keep track of that. And the right side hasn't changed, so I'm going to move on from that. So momentum of my red boat, which would be 0.03994. Again, if you can keep more in your calculator, great. Kilogram meters per second minus, because this blue one was negative, 0.057572, which would give me beforehand total momentum negative 0.017629 kilogram meters per second. Now that has to be equal to the momentum on the other side. So 0.419 kilograms times my final velocity. Last but not least, divide by that total mass, 0.419, and that gives me a final velocity of Vf is equal to a whopping 0.0421 meters per second. Alright, now that came out to a negative value, which means the blue guy won, so they're pushing to the left. So remember, always set up your knowns before and after. Make sure you keep track of that. The momentum before is always equal to the momentum afterwards, and that's going to be where you start all of these problems. And then it's just setting up the momentum for each one and rocking out some algebra.